I hope everyone can see the screen now.
Yeah, very good.
All
Looks
right.
very good.
So first of all, thank you very much for the opportunity, to speak. Thank you very much for inviting. Thank you very much for being here. My talk today we're going to be around IBM approach for data fabric in sustaining AI solutions, and I'm going to have the following agenda. We're going to present a little bit data complexity, some architecture design that IBM has in this direction, the approach we have with the data fabric to sustain machine learning operation. Then I'll go a little bit more in details on what is on the platform. And hopefully then I'll go to show you a demo. So I can, I think the best it would be to show these things with your eyes and see how this is working. And just because I've seen prior mention the anomaly detection, I can introduce you, if the time will allow, some a library we have from IBM Research for anomaly detection that you may use, or we can explore in the sandbox on IBM. All right, so let's go. Always, whenever you want to introduce a new approach, for example, like data fabric, always the question comes why you need to change something which is somehow it's disrupting the way we are working prior, right? So the idea is that in general we are trying to innovate with data, right? Whenever you say machine learning, you need data. Either you do supervised learning, either you do unsupervised learning. The more important you emphasize on the data, the more importance the data will have, either in collecting the data, managing, organizing the data, sharing the data among the researchers. The data is the key, right? Like our previous CEO was mentioning that the data is the new oil. And that is true, right? This is what we actually see on 165, more likely to outperform the probability in general. This is coming from an IBM study called IBM Global C-Suite study done by IBM Institute of Business Value. And 163 are more likely to outperform the revenue with more data, obviously building trusted solutions. And why is important here is that we see more and more that the people working within the enterprise, they see the need of more data, either to harvest from existing data sets they have, or to purchase new data, or to build new data sets by using synthetic data generation as an approach. And that is actually showing that as long as you have more data and more insights, you can harvest more things, either for research purposes, either for the industry-related purposes, but that is the key. So that is actually bringing as well a lot of complexity, because what we have observed is that a lot of data is not really analyzed. And when you mention data, you can, for example, have a look on your existing, let's say, solutions to collect the data. You may analyze that collected data, but what you do with the metadata? Are you analyzing the metadata in the context of the data that you are collecting? How you bring that into the context of a specific research topic. So part of whenever everyone will start a research study or will try to innovate, we'll start with the research, right? What is out there? Looking at the research papers, then looking for data that will be incorporated into the project or into the research study, and that is a lot. So time to access the data is the most important to find the right data. Then the second thing is the data cleaning, integration, and preparation. And when you look from that perspective, we spend a great amount of time, 80%, in this particular topic. The reason is because the data that we found always, even if we, for example, we want to use a regression model, or we use, for example, a deep neural network, we'll need to clean that data, right? To be sure that it's really only the necessary part within the data that will be used for training if we use the supervised learning. For unsupervised learning, again, we'll tend to clean the data anyway. But that is one part. The second part is the integration and the preparation, right? Integrating the existing data has multiple forms. When the data is residing in kind of SQL-related databases, Hadoop databases, you need to bring that data close to where your computing power is, right? So that is kind of an export, import, and then obviously you do the cleaning. And another way of saying this is, well, if the data sits somewhere in S3, an S3 bucket, an object storage bucket, I still need to, connect there and try to bring the data where computing is and prepare it. So that is the one part which is very important to understand where the data is, how I'm copying the data, how I'm going to process where the data is. And typically, that is not a data science related problem, it's more like a data engineering problem. Third is the data quality we have for the projects we want to do, right? And often this is what we see as well within our internal projects in IBM, is that if, first of all, you need to understand your data and then to see, the quality of the data. That means that you need to have an SMEs that will, just say, well, that kind of data set is okay, doesn't have any outliers, or you need to have that kind of an assessment, and that has to happen. And again, that takes a lot of time. Sometimes we identify that the data sets we have, they are not on the right quality that we may need by looking just to the results we have with a machine learning model, or with just an empirical assessment. So the data quality, it becomes a barrier to the entire data integration related projects. Now, 82% of the enterprises are inhibited by the data silos. And here is the question: if the data silos killing your initiatives, right? And it was an interesting study outside IBM by Michael Goldberg, if I remember correctly, and Don Brathwaite in May 2018, highlight exactly the fact that when the data resides in various departments and various business units, the time to go and request the access to the data, identify where the data is first of all, and then get that data, it's a lot of time. And sometimes that time that you spend to identify where, getting the right access, credentials, and so on and so forth, is taking as well a lot of time. And obviously goes on the fact that instead of doing your research, you do all this preparatory work that is time consuming. So that's one side. But now if you look on the technology side, what we can see is that we tend to consume right now data from multiple sources and multiple locations. And that increased the higher complexity in the security, in governance, in risks, questions. For example, whenever you use a data set from research and so on, how do you know that you are allowed to use that data set? Has anyone inspected the license that the data set was provided? So that goes into the governance risk of what we use. in addition, how you discover the topic we're speaking. When the data is, for example, you see here on-prem, you have an Hadoop system, or you have a file system where the data sits collected, for example, either images or sensors data, or anything you may use, for example, text data for NLP and NLU, or use an S3 bucket somewhere on a cloud, or there is another solution somewhere. It becomes complex to bring all together, either on-prem, where your systems are, or you're going to we're going to have the computational power, or somewhere in the cloud where we want to run that. So discovering everything is a problem. Processing all the data in one place from various places is a problem, and doing data engineering from multiple sources is not easy. So now what, right? You can ask yourself, well, yeah, we know this thing, we have noticed them, but what's the solution? So we have the concept of the data fabric architecture that is trying to gather multiple sources of the data into a single data plane, where you can just virtualize the data, right? You can connect with existing data sources, bringing them into a single fabric. We call it data fabric by design. And the data will not be copied. That's the idea. So we want to abstract, we have to abstract the infrastructure layer, and we'll just virtualize the data. That is the first step by doing that. And the reason we want to do this is because you see here the elements of the data fabric is that, first of all, we want to have more like a self-service, right? So like an engine that always will go find the data and try to classify the data and put this data into a catalog. So when someone will need something for his research purposes, we'll go on a portal, we'll try to find the data that we'll need based on the existing catalog that has, we have an automated catalog there that is actually always running in the background to harvest the existing data sources, data, and related metadata. And upon request, he can request the data to the appropriate persons to get access to it if it doesn't have the right access. So it's not just knocking on the doors and other people say, hey, I'm looking for this kind of data. Do you have something, and so on. But that's one part. Then we have the augmented knowledge. This is an abstraction layer that provides a common business understanding of the data, right? So what is inside whenever you want to search something to do a research, or maybe you are looking for a research topic, but you don't know exactly on what kind of basis you should step on. Another thing is we call it smart integration. So we have an integration with all the things that are ranging from ingesting the data, streaming the data, visualizing, and transforming the data on various components. I'm going to speak about it. Then we have the multi-modal data governance, security, and compliance. This is another piece, or let's call it an engine, that will always work in the background to unify the definition of enforcing the policies. What that means? It means that, for example, if you are extracting, let's say, data from an SAP system or IoT data where, for some reasons, you need to mask some information like IP address or the or name of the persons or personal information, you can establish some policies, for example, for personal informations. And when automatically those policies are scanning the data and you are identifying such things, the system can automatically mask the information. So when you consume the information, they will not going to have these kind of things inside. They will not contain, right? And this is one part. You may have policies to classify the information and so on and so forth. So all these things you can imagine you can do with the platform. And that is something that you can enforce by whenever you are looking to say, well, I'm going to consume data for my machine learning models. And the last one is the unified lifecycle, right? So an end-to-end lifecycle to compose, build, test, deploy, and manage. That goes into the machine learning operation, that goes into the data operations method. And I will give you as well an example. Hopefully you will see this in the demo. And obviously, the ultimate is to offer a solution that really works on every platform and every cloud, right? As long as you have an OpenShift based system. So that's the goal, right? We have with Data Fabric. Now, the value delivering by the connecting the right people with the right data always at the right time, you can see it here. 65 million in income drive by a 10% increase in accessibility. This came from measuring some term investments of the data quality of data-driven marketers. I think it was done by Forrester in a Forrester study. 50% of reduction in time to deliver unified data to the users, 25 to 65 reduction in the enterprise transformation ETLs requests. Again, this comes from another Forrester new technology projection of the total economical impact. So things at scale on the enterprise, they go in this direction, and they see the real value of approaching the data fabric architecture and related platform, which are based on that. So how we do it, right? So our vision is to make as simple as possible and transparent. So to give a platform that all those features are included there, right? So for example, if you look here on some components of the data fabric design for data-driven organizations, everything starts with I was mentioning at the beginning, with the preparing and organizing the data, where we have a component called Watson Knowledge Catalog that has three main characteristics, I would say, or missions: data profiling and preparation, quality and lineage, and policy-based governance, right? This is the first entry point if you want to consume, to understand where the data is and how we can consume that. Another thing is the build and train AI models. There we have the Watson Studio, another component where we can visualize the data, we can train the data, and obviously we have the whole lifecycle management. So we can see the models that we train, the hyperparameters. We can use even something more advanced called fact sheets. So we can file all the training and all the things we have done into the system. The third is where you deploy those models, right? You may want to say, well, I did train, I did find some good results. Now I have a model, either it's a pickle file or it's a H5 file, whatever, that's your model. Now, how you really serve your model. Let's say you want to make some tests and you want to expose that model to an API so that then you can consume that model from various applications. So for that, we have the Watson machine learning that can really run those models and optimize them. It's doing the model operation, obviously, monitoring the model, and based on defined policies, a dynamic retraining. And then we have the explainability, right? Most probably you have seen a lot about the explainability of the models that we deploy and how you can really do that, right? So we have the Watson Open Skill, another component on the platform that can deal with the business KPIs and have the explainability and fairness embedded. So it's actually monitoring the models we have in production for explainability and fairness, but as well for data drifting, which is another important concept when you have models into the production. And yeah, you can say, well, that's something like I can do. But on top of this, we have multiple things that we can add. And hopefully I will show a couple of them into the demo. So ultimately, the benefits that Cloud Pak for Data and the Data Fabric is bringing is the intelligent integration. It's a lot of tremendous work, I would say, put it by IBM development into the product to integrate all those pieces together in an automated fashion. Unified governance to automate, protect, and secure the access to the data. And the third one, we call technology insights. It's the self-service for consumption, right? Either you consume a training session or you consume data. That's something that we want to bring. Now, if you say on the benefits, obviously you need to understand that, you know, I need to have some benefits to go in this direction and into this approach. From the technical team perspective here, you see decreased effort to maintain the data quality standards. So that's something that, you know, probably I've seen always whenever you are working on a project, you may have 4, 5, 6, 7 versions of the same data set, because always you try to clean it, you try to improve it, adding additional data to it, and so on and so forth. So that's something that this platform can do. Then reduce infrastructure and storage cost, obviously, that is associated. Faster and simple data delivery process, because I know where the data is, I can request to get access to it, and then for example, I can have a Jupyter notebook that automatically have seen that data, and it can, with the click of a button, it can bring that particular data set as pandas data frame, right? So I don't know exactly, I don't have to write again the script, where is the data, put all these things, and so on and so forth. So that's something that the platform can recognize and do for us. And then we have the reduction in effort for data access management, obviously, and improve regulatory compliance, especially for more regulated environments. Let's say you are working with on a research project with some data which is should be regulated, who has access to it, why, and so on. So if you don't have a platform like this, you cannot actually work with that kind of data, because you cannot prove the audit. You don't have the audit in place and the whole mechanism to enforce some policies. On the business side, probably they are not too much for importance for you as university, but I think you should be aware that there are a lot of business benefits on this. And I will just want to highlight here the increased compliance and security that nowadays is the most important on the data leakage and all these things. Those are important, and accelerated time to value, right? So whenever you want to do a project and you say, well, I need to come with a machine learning model in, let's say, 3-4 months, you will probably spend at least 2 months on the data related topics. So how you can decrease that, decreasing that time that you spend, you can come up much faster on the market with the machine learning model, for example, that can do a scoring or whatever will be needed. So if we look on some use cases, we can see these 3 or 4 patterns: data governance and privacy, multi-cloud data integration, customer 360, and MLOps and trusted AI, where I will focus a bit more the discussion for today. So on the data governance and privacy, we see the AI augmented data catalog, allowing users to easily understand and collaborate and reach and access the right data. The metadata governance layer for all the data and analytics. And here is another question you can ask yourself, well, how we manage our metadata, right? It is, and if yes, is that, if not, will be valuable for us to have always the metadata associated with the data we have? Probably yes, probably no, depends on your point on and usability on that. Dynamically and consistently mask of the data at the level of the user. Facilitated anonymized training data, like I mentioned, and creation of the test sets while maintaining the integrity of the data. Another important topic whenever we speak about the governance, right? All these things, they come with the benefits, which are highlighted here, that typically they go to the productivity side, right? The multi-cloud data integration, as you have seen in the beginning, was that chart where you had multiple sources of data sitting in multiple clouds, on-prem, off-prem, and so on and so forth. Whenever we want to prepare the data and use, for example, ETL, or we want to use data virtualization, you need to have a system that really is able to, combine all these things. And I think this is the most important thing if I will say, I will want to highlight today about the data fabric implementation on IBM Cloud Pak for Data, is that it's a platform that is bringing all these things together and in an integration, in a highly integrated way. Yeah. So then we have for this capability to build and quality and analyze remediation, capability to write your own data pipelines, either use Watson Studio ML pipelines, or you are just writing your pipelines in different notebooks and you schedule them, that it's always possible, or your ETL pipelines as well. I was mentioning the MLOps, but again, it's the data ops as well to the whole life cycle of a project, which is very important. So I will, so just mention briefly the Customer 360. This is more for projects where you are working to understand more the entities, right? Into an organization, to have a 360 view around an entity, around the integration and the collaboration. For example, understanding a specific customer for a bank, right? From multiple interaction of the bank with that customer. It means that you need to connect to multiple systems and then do the analytics, trends, patterns, and so on of interaction of that customer. And Customer 360 actually go in simplifying the data modeling for data first approach in working with single entities, and obviously multiple entities at that level. Trust of the AI and machine learning operation, probably the most important topic for today. It's built for compliance and scalability into the platform. It has the capability to monitor the models as mentioned, explain, find the draft, the biases, fairness, and the quality over the time of the deployed models, and integrate the data governance with data science to provide end-to-end trust. One of the problems we see is not in the research, but just keep in mind that whenever we give a model to someone to put in the production, we need to have a way to monitor that model in the production. Or if we have tested that model, even into a kind of a pilot, do we have the proper technology in place to really, look for explainability, draft, biases, fairness of that model? So when we push that model further, or when we publish a research paper, we're sure that the quality of the work that has been done and put it into training the machine learning model, and it was a quality work, right? So and this is a way you can really automate all these things. So here are some examples I will give. ING, it's a bank in Europe, in Netherlands. They had some challenges, as you can see here on the left side. The data was mixed on disparate data silos, both legacy and modern capabilities of SQL, related databases, and Hadoop. Here is numerous industry regulatory requirements. They had to comply in accessing the data, querying the data, a lot of things. Always in the banking they have to comply with in terms of data access. Data insights initiatives were often slow or delayed, and they were actually looking to have a solution that not only that will cope with this, but as well will comply with the GDPR regulation in Europe. They have adopted the data fabric for the things we mentioned, but mostly they are leveraging the data virtualization for existing on-premise investments with data to remove the data silos. That's something that, I think it's a very successful case we mentioned. Another global telco is actually using data fabric. That in that particular case, their let's say reason to the cultural reason was the low user productivity due to the bureaucracy to get access to the data, especially when I was sitting into a different departments and so on and so forth, and the sensitivity of the data. And not all the people in organization, they are, let's say, allowed to work with all the data that the company has. So you need to understand how you can do this, how you can give the clearance based on what kind of policies, and know how you can automate all these things. So again, those were the good, I would say, thing I was wanted to mention as an example. So if you say, well, okay, let's say I will try to understand this. So as a recap, right? So for the data governance and privacy layer, right? Multi-cloud data integration, customer intelligence, what are the three main things to take? So for a single use case, in general, you are trying to virtualize the data, connect to the data sources you have, catalog the data, and then try to consume the data, right? That's a simple thing. Whenever you have multiple use cases or multiple projects happening, it's the same thing, but it's at scale. That means that you need to discover, master, curate data domains, and promote the data into the data catalog. So it could be found, shared, and consumed on multiple projects. If you have multiple business units or organizations or departments that typically are siloed, they can start working together into a single platform, although they can keep their own data and they can share based on existing policies that they have defined. So they resolve this cross-organizational data sharing, which is real. Yeah. So from this perspective, the solution can really work on-prem, on power systems, OpenPOWER, and or infrastructure as a service, platform as a service, or full managed. It's a matter of choice. So let's look a little bit on more interesting thing, probably from the technical perspective, is the Cloud Back for Data reference architecture. So what we have are the data sources, and we can say, well, machine and sensor data, image and video, social data, internet data sets, weather, commercial, third party, all these things. System of records, typically they go in the SQL related databases. And then we have this process of data acquisition, right? So all these things like, hey, give me access or do an export. When you say give me access, you need to create a user, a password, give the right permissions, all these things. And then you ingest your data. Is that a layer that you have? Then you have the analytic data management and storage, where you need to analyze these things, train your models. And then you have the data access. For cases where you are working with data in motion, you need to do the analytics for the data in motion. So that is another challenge. Obviously, we have some discovery and exploratory. When you say discovery and exploratory, it can range from looking into the data, visualizing the data, for example, creating some dashboards, understanding outliers, trying to see if your data sets that you have and you want to include it are imbalanced, and so on and so forth. And you need to have at the end some actionable insights, right? You need to create a model, expose that model that will be able to give you those insights to predict something. And then we have on the right side the enhanced applications, things from customer insights, business models, forecasting. Those are applications that they're going to come and consume that machine learning model. And obviously the platform needs to offer the security, information management, and governance. This is crucial. So how we map these things? So for example, for connectivity, we have Apache Spark. We have a component called Data Stage that has a flow designer, so we can have those pipelines implemented there. In terms of storing the data, we can provide databases, relational databases from DB2, MongoDB, PostgreSQL, Informix. We can actually store the data if needed. In case they are not virtualized. In terms of data access, we can virtualize all the external data. So we don't copy the data, we just have a connection to the data, and that we can consume much faster. We can even create virtual tables. That means that you can consume multiple data from multiple sources and create a virtual table that you may need. And then we have on the discovery and exploration, the components I was mentioning prior, the Watson Knowledge Catalog and Watson Studio, where you're going to look for your data, you're going to have a catalog, and you may actually have the data raffinery process in place. In terms of actionable insights, I was mentioning prior the Watson Studio, where you work to the Jupyter Notebook or RStudio. For example, to build the models, OpenScale to monitor Watson machine learning, to train your models, to deploy your models that you have trained, and ultimate cognitive dashboards. This is just, whenever you want to build dashboards, it's very easy to consume them from the platform. And then we have the typical things that an information management and governance platform should deliver, right? From business glossary, data lineage, reference data sets, metadata, governance, data quality, all these things, they need to be in the platform. So that's something we try to offer with the data fabric implementation in the Cloud Pack for Data. And on top of this, obviously, we add things like the Watson Assistant if needed, Watson Discovery, when you want to build more complex virtual chatbots, that they not only they need to have the NLP and NLU part inside, but as well they need to do information retrieval, entity recognition, and so on and so forth from existing organization documents. So they are just plugging to the solution. But ultimately, this is what we want to deliver in an automated and integrated way. So obviously, you ask yourself, yeah, but we can run it on cloud, and so why OpenPOWER? Why Power, right? There are three important things we see. It's the relevancy, quantifiable value, and differentiation. in general, because of the way the Power 10, Power 9 processors have been built and the related systems, we see a better performance per core, driving, you know, more software value with less servers, and obviously more bandwidth, you know, CPU to memory. That it's something that we see. By having this, obviously, it's the energy topic today more and more often. We see a less carbon footprint, obviously, compared with the x86 related enterprise database systems, and obviously more reliable mainstream servers that typically in practice, in production, you may want to have, don't want to, you know, always try to solve these hardware issues and so on and so forth. In terms of differentiation, we have the infused machine learning algorithms from GPU-based power systems, or probably Intel systems, or AMD, whatever, with inferencing for core business apps to Power 10 servers. And that is reducing the latency across fabric by LPAR to LPAR data transfer across workloads. So it may have different partitions where within the same system, where in one, for example, you can run the inference, your models, and in the other one, you can have the business application that will consume that. So that transfer, that exchange of the data, it's faster because it's happening into the system. So those are some key things that you know, always it makes us think twice whenever you choose the right infrastructure platform for the software stack. So now I will show a demo of the platform just to show you how those things are working. So let me go like this. So right now I'm in the Cloud Pak for Data. So whenever you enter, you have a couple of things here. You have things like projects, your own projects that you are collaborating with with others. You have catalogs, for example, like I was mentioning with the data sets, with models, and so on. The governance, where you can define business terms, business classification, all these things. Deployments is where typically you will tend to deploy. I will come back to this, your machine learning models. Service catalog, you have services running. Gallery, for example, you can say, well, I do have for teaching, I'm defining some particularly tutorials and so on that every person can go and take them and try to work with them by adding to a project. So it's very simple thing, right? So it's you can use it as well for fast onboarding on the platform, quick learning, not only for productivity, right? So for real work. And then we have some, typical administration around the platform. We're not going into this one. Platform connection, I was mentioning, and the data virtualization, always we can see them from here. Let me go right now to one of the projects I have here. So my goal is to give you a couple of things around the platform right now, so you can understand. So I was mentioning in the presentation that sometimes you want to connect to a platform, right? Or either to virtualize the data, or either just know, okay, I don't want to copy the data, I just connect to it. So for that particular case, we have this option here called data access, connections, and in this case, I'm connecting to a DB2 warehouse to retrieve the data that I need. So you can put your username and password there, and you can connect, and that's the thing you need to do. And then you just import the data, and I'll show you immediate how this can be done. Have other options with location sovereignty. This is, for example, to say, well, that goes into the data locality. So you can set a location for particular data, and and that especially for whenever you have multi-cloud, that data will not leave from that particular location. Another thing is that you have the data. So you may decide to create new data, obviously, or to import CSV files directly into the platform. So it's very simple to drag and drop files here. That's something which is possible. And then from the platform, we can go and explore the assets you have, right? So for example, this CSV called Gold Bank holdout data that we use to train a model is just showing all the values, all the rows here. We can have some visualization capabilities. And right, we can create some dashboards directly from here if needed. So all these things we can have them automatically, and we can explore them from the system. And that is good for the visualization part, right? To understand on the first place the data. Another thing are the source codes. Those are notebooks, right? And in the source codes, what we're going to to typically see is how we import the libraries, all these things that you work with the notebooks, right? Either you upload them, or you create them from the scratch. Those things are there, right? And you can very easily work with the platform. And I was mentioning the fact that you can import, let me edit. You can import automatically the data that you have in the CSV file with a single click, and I will show you into the pandas data frame, and I will show you how that can be done. But again, that goes into the direction of that kind of productivity, so low code, no code direction, especially when you want to consume the data. That's something that the platform can offer for every related project. So let me go somewhere here. So this is a way you can just connect to the data set and import it. But in this case, I will create a new thing here. So what we do, we have that file, that CSV file, and we can import the file from here. And you can see we have this automatically recognized that in the project, I do have this Golden Bank holdout CSV file, and I have this this option with insert the code as pandas data frame or credentials, and I would prefer as pandas data frame. And automatically the system will actually bring me all the necessary things from my project, and then obviously I can automatically read the file I do have there, right? So that is something very, very simple you can do in training your model, and then up to the fact that after you train the model, I think actually in this morning, you can save your model into the project. And I think it's somewhere here at the end. Yes, this is the model. We did the confusion matrix, and then we put a name for the model, and then we saved the model that we created into the project profile. So here is a project, and this is the model that I trained. It's a scikit-learn. It's using obviously scikit-learn, but you can use it TensorFlow, PyTorch, all these things, and it's showing as well the input schema that the model is actually expected and it was trained on. And then you have this option here, promote to a deployment space. So we have the Notion. So in this case, you decouple. So this is the exploratory part, the training part, finding hyperparameters, creating the best model, and so on and so forth. But if you want to deploy this model into the deployment space, you go to here, and then you have the deployment space. And here is a way you can actually monitor your models. So if I'm going to assets, I'm saying, yeah, I do have this model. I can put it as online or batch. I prefer to have an online, give a name. 1, 2, 3. Once be okay, MLOps. Just give a name here. More things. Include 0, 0. Try to leave it like this. Yes. And this will deploy my model in the production. That actually will create a container, will take the model, will put all the APIs needed, and will expose the APIs and IP address where I can consume from an application, right? So you can go here. There is a link to the model. We actually give even a Python called Scala or JavaScript that you can take and reach the model and score against the model if you need it. Another thing, and I will finish, and I'm conscious about the time, when you go on the projects we have here, for example, I was thinking about collaboration. You can go on the manage and have access control, so you can invite other collaborators. For example, Magda, it's one of our colleagues here, so I can invite her and say, okay, you are admin role and viewer, and she can come and collaborate with me, seeing all the data I have, all the notebooks, and so on and so forth. Another important thing is that you can always, if you look on the source code, you can bring new assets, and that can be, for example, auto AI, can be decision optimization, SPSS model pipelines, even federated learning, right? So all these things can be brought to the platform, and you know, that's kind of very simple to bring all these things. I need to associate some services, but those are very simple to be added with a couple of clicks. So it's not that complicated to bring right into the platform. So this is answering from a single interface on all these type of the problems that yeah, typically we're going to see when we work with the data, when we try to train models and so on and so forth. So I'm conscious on the time. I will stop here. If there are any questions, I'm happy to answer.